In this video, we are going to be learning about the law of conservation of matter and the law of conservation of mass. The law of conservation of matter states that matter cannot be created or destroyed during a chemical change or a physical change. This means that the number of atoms of each element before a change occurs must be the same as the number of atoms of each element after the change. Hydrogen remains hydrogen, nitrogen remains nitrogen, and the same atoms are present before and after the change. It is not possible to change hydrogen atoms into nitrogen atoms or oxygen atoms during a chemical reaction. Because matter is conserved, mass is also conserved in both chemical changes and physical changes. The total mass of everything before the change occurs will be equal to the total mass of everything after the change because the same atoms are still present. Here is an example of how we can use the law of conservation of mass to solve problems. This question states that baking soda decomposes when heated above 176 degrees Fahrenheit to form sodium carbonate, water, and carbon dioxide. A recipe calls for 1 teaspoon of baking soda, which has a mass of 5.00 grams. If the reaction produces 3.15 grams of sodium carbonate and 0.54 grams of water, what mass of carbon dioxide is formed? Later, we will learn more advanced methods for solving these problems using balanced chemical equations and mole calculations. However, this question can be solved using the law of conservation of mass and subtraction. We know that the mass before the change occurs must be equal to the mass after the change occurs. Since we start with 5 grams of baking soda, we must end with 5 grams of products. We can determine the mass of carbon dioxide through subtraction. 5 grams minus 3.15 grams of sodium carbonate minus 0.54 grams of water gives us 1.31 grams of carbon dioxide. This graph shows the conservation of mass. Before the reaction, we have 5 grams of baking soda. After the reaction, we still have 5 total grams divided among sodium carbonate, water, and carbon dioxide. This image shows us water boiling. Each water molecule consists of 1 oxygen atom, shown in red, and 2 hydrogen atoms, shown in white. This represents what water would look like at the molecular level. Which picture best represents water vapor? To answer this question, we need to recognize that changing from a liquid to a gas is a physical change. Physical changes should not change the composition of matter, so water must remain water. We still need to have 2 hydrogen atoms bonded to 1 oxygen atom in each molecule. The first image shows H2O molecules, so it is the correct answer. The molecules are just a little bit further apart. The second image is incorrect because the molecules have changed into H2 and O2 molecules, meaning the chemical composition has changed. The last image is also incorrect because hydrogen and oxygen atoms are completely separated and no longer bonded together.